Hi again, guys. Today I am doing examples from grade 9 and grade 10 for electricity. So grade 8s, you might understand the first couple of them. Grade 9s, you should be able to do somewhat most of them, except like there's one or two that probably is not for you, which is the last example 9 and 10. And then grade 10, the first 8 examples are revision from grade 9, and then examples 9 and 10 are for you that you could expect in your grade 10, which are very average questions, not the difficult ones, just very average. Grade 11s and 12s, you can use this video as a revision to be able to understand basic electricity, just so that you get a reminder from grade 8, 9, and 10 so that you can do better in your electricity, because a lot of kids struggle so much with these concepts that it's difficult then to do it. And remember, matrics, like a third of your physics paper is electricity. So if you don't grasp these basic concepts, you're not going to be able to do the slightly higher powered questions. You're not going to be able to do internal resistance and all those things. Okay, so let's start. So example 1 just eases you into it. It's just a basic series circuit. It's only series, there's no parallel. You can use your highlighter to figure that out, but it's just a really basic example. Okay, so it says calculate the effective resistance. There's that word effective. It just means total, effective resistance total. It's just the correct scientific term to use when the question is asking you to find out the total resistance of the circuit. It says each resistor is 3 ohms. So that means this one is 3, this one is 3, and this one is 3. The beauty of a series circuit is we just add them together. Depending on how many marks it is for, in grade 9, they might want you to give an equation. R total is R1 plus R2 plus R3. Okay, so they might want you to actually show your working out. Just look at what the mark allocation is so that you can work it out. Okay, in grade 10, obviously you would just get a mark, maybe 2, probably just 1 for the answer. Okay. For my grade 9s, I would give a mark for the equation or a mark for the substitution, depending on what the phrasing is of the question. But it's nice and easy. Okay? It's just a series parallel, a series circuit where they're asking you to find resistance. Here, okay, is a slightly different example. Still 3 resistors in series. Each resistor has their own voltmeter over it. Remember, voltmeters are in parallel over whatever they're measuring. This battery over here, remember, a battery is more than one cell. This battery, this dot, 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 is just showing you there's a whole bunch of cells in between this one and that one. That's all it's saying. Don't let it confuse you. Don't get confused. Don't take on any unnecessary anything from a question like this. It's just saying that there's extra cells inside there. And it's telling you that the V total, I like to call this the V total, is 40 volts. So it's just saying what is leaving the cell, the batteries, is 40 volts. So as it's going down here, there's 40, there's 40. And then as it enters this resistor, obviously each resistor is going to use a different amount. They want me to calculate what is V. Okay, I'm going to label this V1 and this one V2. Just for me, I like to label things. We know when resistors are in series, we just add their voltmeters together and they should equal V total. So V total should be V1 plus V2 plus V3. Okay, grade 9s, it's always nice to write the equation out. Grade 10s, you don't have to. You just can write the answer. Okay, we know V total is 40. We know V1, it says there's 18. We're trying to find, I've labeled this one V2, so this is going to be 10. And this one is V3 is the unknown, is what they're asking us to find. Okay, so I'm looking for V3. Oh gosh, what happened there? V3. When we got an 18 and a 10 is 28. When I bring it to this side, it becomes a negative. So that means this is 12 volts. Grade 9, maybe they want to see your substitution and answer. Grade 10, you'll just get the mark for the answer. Okay, nice and easy. It's just a process of knowing that V total is 40. You have V1 and V2. You can solve for the unknown. Okay, pretty easy one for grade 10, and obviously that you could get it in grade 9 as well. Okay, here's the next one, still series, so still part of the series circuit. They are telling me that this cell is 10 volts. This voltmeter is still over the cell. Just instead of it being up and over, it's underneath. It's still measuring the cell. Again, don't take on unnecessary stress. It's just over the cell, but instead of being depicted as over, it's just going under, still measuring the cell. So don't get confused. So V total, they've given me 10 volts. I'm going to label this one V1 and V2 just because I like to do it. So V1, they told me is 5 and V2 is 5. I like to write down what is given on my piece of paper so that I have it all written down. Calculate the current for the whole circuit. So I am looking for I total, the total current in the circuit. So if there was an ammeter here, this is what I would be looking for, okay? So that's what I'm trying to find. If both bulbs have 2 ohms, so that means I'm going to call this one R1 and I'm going to call this one R2. So R1 is 2 ohms and R2 is 2 ohms. They're both 2 ohms, okay? They want me to find I total. So to find I total, I must have V total and R total. Okay, I need to be able to have all of the totals. I can't just use one of the 5 volts. I can't do that because I need to use the total to find the total. So the equation would be I like to say R total is equal to V total over I total. In grade 8 and 9, you might get given this equation. In grade 10, it's not on the data sheet, but grade 11 and 12, it is on the data sheet. So just do with it what you will. So this is the equation we're going to use to find I total. So do I have the total R? I don't have the total resistance. They told me both of them is 2, but that's not giving me the total. But what do I know for resistors that are in series? I just add them. So I'm just going to do 2 plus 2 here within the calculation. You can straight away put a 4, it's fine, it doesn't matter, but use 2 plus 2. V total is 10, and I can then solve for I, okay? Those of you who like to use the triangle method, okay, it's V, I, and R. So then we have 10 divided by 4, or you should just know that you can swap these two around, or when you bring this up to this side, it becomes a times. When you bring this one to this side, it becomes a divide. That's maths. Your maths teacher needs to teach you that. Okay, so I is actually 10 divided by 4. You don't get a mark for this. Don't rearrange it. You get a mark for equation and mark for a substitution into this equation. Not this. We don't want to actually see you do that, but you need to do it. So, okay, so your answer is 2.5 amps. Okay, this would maybe be for 4 marks like this in grade 9. Grade 10, it would only be for 3. Okay, so that's a really basic one where we're working with R is equal to V over R. Okay, so for question 4, example 4, this is a series circuit. There are only series resistors, series light bulbs happening here. So if you can see, there are also 2 ammeters. We have an ammeter 1 here and an ammeter 2 there. We have 2 light bulbs. Remember, light bulbs act as resistors. So there are 2 resistors over there. This is just V, this is V1, and then this is V total. So they're giving us the total voltage. So they said that VT is the 15, okay? They then said in the equation that V1 reads 10, V1 is 10, okay? They've then also told us, I'm going to call it R2. R2 is 3 amps, okay? We don't know what R1 is. So R1 is question mark. And V1 also, we don't, they've told us V1 is there, so V2 is also unknown. Okay, so we don't know those two. So when we are trying to calculate the reading on A1 and A2, we need to make sure that we know that we are calculating A total, the total current going through the whole circuit. I have V total, I need to find I total, and maybe I can find R total. But the problem is I have the 3 ohms, but I don't know what this resistance is. So I can't find R total. There must be another way to do this equation without doing R is equal to V over I first. So if you look at what information is given, let me just erase this so that it's a little bit clearer. When you look at all the information that is given, we can then determine what the question is actually asking us. Okay? So they gave us V total and V1. We can find V2 from that. So V total, okay, is going to equal V1 and V2 together. V total is the 15, okay? V1 they told us was 10 and V2 is the unknown. So we need to solve for V2. So we know that V2 is going to be 5 volts. So now I have V2. So this one is 5 over here. We have resistance, which is 3 over there. I can now find the ammeter reading on A1 because remember, this is a series circuit. So all we have to do is go R is equal to V over I. Remember, this is not given on the data sheet in grade 10. You only get it from grade 11. Your R is the 3 ohms that's given. The V is the 5 volts that I already found out in my previous equation. And I is what I'm trying to find. So when we swap the 3 and the I around, it's 5 divided by 3. And if you say 5 divided by 3, let me just go, I is equal to the 5 divided by 3, and we get 1,67 amps. So for this one, your answer is 1,67 amps. So if they had given us the resistance here, so let's say they gave us 2 ohms, you could have had the V total, you could have added these 3 and 5 together and then got the I total. But you don't have this. So there must be another way of doing it, which in this case was to find the I that this part of the circuit uses, because we know that no matter where you put an ammeter, the reading will stay the same in a series circuit. Okay. Okay, so that takes us on to the next one. So here's example 5, and again, it is a series circuit. So we're just going to know that this one over here is in series with R2 over here. Okay, so R1 and R2 are in series. Remember, in the voltage, when we see this dash, 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 it just means there's a whole bunch of cells, one after each other, and it comes to 12 volts. Okay, this voltmeter over here is only over R1, so it's only going to be measuring R1's incoming electricity and outgoing electricity current. Okay, calculate the reading on each of the resistors if they have the same resistance and current is 3 amps. So they're telling us that they have the same resistance. So if R1 is 5, then R2 is 5. Okay, so they're going to have the same resistance. We have our V total. So V total is going to equal 12 volts. Okay, so we have V total. We don't know what V is. I'm just going to call it V1 because it's attached to the R1. We don't know what V1 is, and we don't know what R1 and R2 are, but they do tell us that the current I is 3 amps. So R1 is getting 3 amps and R2 is getting 3 amps. So they're both getting 3 amps. Okay? So the reading on each resistor if they have the same resistance. So we have V total and we have I total, which means I can find R total. R total is equal to V over I total. Okay? So we've got the 12 and we divide it by 3. So 12 divided by 3 is going to give me my 4 ohms. But that's not what the question asked. The question asked us to calculate the reading on each resistor. So we know that the total resistance is 4 ohms, but there are 2 resistors here. Because there are 2 resistors and the resistors are in series, we know that we can just add the 2 resistors together to get the total. So with this 4, all we have to do is divide by 2, and we know that the answer is 2 ohms each. So each of those resistors is going to get 2 ohms. So it's a pretty simple idea, but it's just working backwards. Okay. So here we have example 6, question 6. It says calculate the effective resistance. There's that word again, effective. Another word for effective is total. So calculate the total resistance of the circuit. There are two ways to do this, but I'm just going to do the one way. Okay, so here they've given me 6 volts. So we know V total is going to equal 6. Here they're telling me that the ammeter A1 is 3 amps. What you need to realize is that this ammeter is in the series part of the circuit. So the ammeters in the series part and the 3 ohm and the 4 ohm are both in parallel. So 3 and 4 is in parallel. So they gave me V total, but they also gave me I total, the total current in the series part of the circuit. So we do have V total and I total. So we need to work out what the effective resistance is on the circuit. Okay, so by putting the 6 and the 3, they're actually confusing it a little bit because they want you to think that you need to use those, but you don't have to. Okay, you can, because you can go R is equal to V over I. Okay, so to find R total, you just go V, which is 6, and I, which is 3. 6 divided by 3 is 2 ohms. Okay, so that would then be the answer in that way. There is another way to do it if you want to do it. You don't get the same answer, but that's just because it's a made-up question. It's not actually a mathematically correct question. But the other way of doing it would be your 1 over Rp is equal to 1 over R1 plus 1 over R2. So we know R1 is 3. We know that R2 is 4. So 1 over 3 plus 1 over 4. Common denominators between 3 and 4s, okay, it's going to be your 12. 3 goes into 12 4 times, 4 goes into 12 3 times. So 3 and 4 is 7 over 12. We can't leave it like that. We've got to say 12 over 7 because it's 1 over R parallel. What you do to the one side, you must do to the other side. 12 divided by 7 is 1,7 ohms. So these are the two ways you could do the same equation. So they kind of want you to do this way because they gave you V and I, but you can do it this way as well. Even though the answers are different, it just means that the question was not a good question and it was just not mathematically correct. But both ways are correct if you're going to do it that way. So this is example 7. Over here we have a light bulb. Remember, we know that light bulbs act as resistors. And over here we have a light bulb. We know that they act as resistors. Okay, so these two light bulbs, which are resistors, are in parallel. V1 is over the first one and V2 is over the second one. We have an A1 and an A2, but these two ammeters are measuring the parallel section only. This ammeter is measuring the parallel section only, whereas this ammeter is measuring the series portion. So it's very important you know which of the sections the ammeters are measuring, because once you know that, then it makes it a little bit easier. Remember we said that A3 is the series portion. Okay, so A3 is the series, so that's going to be our total. And we know that A1 and A2 must equal A3 because they're the ones in parallel. So this is what we're going to work with when they ask us to talk about the ammeter readings. So if ammeter A3 is 4 amps, so they're telling us that this is 4. And the ammeter A1 is 2,6. So ammeter A1 is 2,6. Calculate the reading on A2. So that becomes quite easy. We're just solving for A2. Okay? So A2 over there is going to equal your 1.4. Okay, so A2 is going to equal 1.4 amps. So that would be your answer to that. They're just testing, do you know that the ammeters in parallel add up together to equal the total in the series part of the circuit? Okay. Then it says if V total, so your V total is now going to equal 6 volts. What is the voltage reading on V1? So remember, this light bulb and this light bulb are in parallel. And we learned in the previous video that when resistors are in parallel, the readings on the voltmeters stay the same. And as long as there's no series part of the circuit, if there's no other series part of the circuit, these two will equal the voltage that is over the cells. Okay, So that's one of the rules. It's how it is in real life. If you do the maths and things, you'll notice that that's how it actually is. Okay, so we know that the V total is going to equal V1, which is going to equal V2. So they're asking for what V1 is, and all you have to do is say 6 volts to get the mark. Okay, they're testing, do you know that in a parallel section here, that the voltmeters are equal to what is over the battery? But do remember that as soon as we add another section over here that is in series, these can't possibly be 6, okay? Because then that means only the parallel section is using all the electricity. There's no current or electricity left for this resistor over here, so they couldn't possibly be 6. Okay, last one is to calculate the effective resistance. We can't go 1 over R parallel. So remember 1 over R parallel? We can't do that because we don't have the resistance of those. So we can't do 1 over R parallel. So there must be another way. We already have the total voltage and the total current. So we can just go R is equal to V over I. R is what we are looking for. V is that 6 that they gave us. I is the 4 amps that they told us it was. Okay. The beauty of this question is to test whether you know that it's 4, 2.6, or 1.4. Okay. So they're testing, do you know that it is the 4 amps and not the other 2? So 6 divided by 4 is your 1.5 ohms. Okay. So there, it's just as easy as R is equal to V over I. Okay. Okay, so this one over here is we are looking at a normal simple circuit. There we have one resistor, we have one ammeter that are in series, but now our cells are in parallel. And how did I teach you to work out cells in parallel? Here it says, calculate the total voltage if each cell has 4 volts. So there are 3 of them. So all you say is 3 times the 4 will give you 12, yes. My brain was saying 4. I have no idea why. Okay. 3 times 4 is the 12. But because they are in parallel, what do we have to do? We have to divide by the number of cells. So we take the 12, we divide it by 4, and our answer is still 4 volts. Okay. So in grade 8 and 9, you could say that it would be for 2 marks. In grade 10, it would just be for 1 mark. I've never seen a question like this asked in 11 and 12. It's too easy. But I have seen it asked a few times in grade 11. Okay. So that would then be to calculate the voltage if the cells are each 4 volts. Then, to calculate the current of the resistor, if the resistor is 5 ohms, nice and easy, because you just use your R is equal to V over I. They told us that the resistance is 5. Okay, we are trying to find I, and V is 4, which we just worked out, and we can solve for I. I don't know where my thing went there. So to get the I by itself, okay, you're going to say I is equal to 0.8 amps. And that is your answer to that question. Okay, this question now is relating to mainly grade 10 and 11s. Okay, so grade 10, this would be a very average question for you. Grade 11s, this would be an easy question because it doesn't have EMF and it also doesn't have internal resistance. So this is just a normal grade 10 type of question. Not too difficult, but also not the easiest one for grade 10s, and then obviously quite an easy-ish one for grade 11s. You could expect something like this maybe in your finals, but it would generally incorporate internal resistance. Okay, so it says calculate the effective resistance. There's that word again, effective. It just means total, effective resistance of the circuit. Okay, so what we need to realize is that this over here, and it splits. So that means this part of the circuit is in parallel. Okay, so these two are in parallel with each other. So we need to treat them differently because they are in parallel. But then as we go through the 4 ohm resistor, it is in series. And we know that when something's in series, we just add them together. So I can't do one calculation. I can't say 3, 6, and 4. I've got to treat them separately. I've got to treat the parallel section separately and the series section separately. So what I always advise is to do this parallel part first. Okay, so 1 over r parallel is going to be 1 over r1 plus 1 over r2. Please don't skip putting in your equations and substitutions because that's where you get the marks. Okay, so this is 1 over 3 and this one is 1 over 6. The common denominator between 3s and 6s is 6. 3 goes into 6 twice, 6 goes into 6 once. So this is 3 over 6, which becomes 6 over 3, which becomes 2 ohms. Okay, so we know that that is 2 ohms. But our total is equal to the series portion and the parallel portion. Okay, so the series portion is 4 ohms. We already know that. It's over here. We don't have to do anything. They gave us 4. So that's 4, and this would then be your 2. So the total voltage would then be 6 ohms. Okay, it's a very normal grade 10 question. You need to be able to do your parallel part and then add it to the series. Okay, so it looks intimidating, but it's really not. You just break it up into parallel and series, and then you can work it out. Okay, the next part then says calculate the current strength. So we know we are looking for I. Okay, so we have R total, which is the 6, and we have V total, which is 12. Okay, so we have those ones really easy again. Your R is equal to V over I. R is your 6, V is your 12, and I is what I'm looking for. The I and the 6 swap places, and you can then say 12 divided by 6, and 12 divided by 6 is 2 amps. Okay, so your answer is 2 amps over there. So the more challenging part is the top one, but then obviously it becomes a little bit more easier in the second one. But if you got the 6 ohms wrong, then the problem then comes in here. This mark over here becomes positive marking. So you can get a positive marking there, but then this one would then be wrong because your answer is wrong. Okay, in science, we don't do continuous accuracy. We only do positive marking. Okay. So this is the last one. This is example 10. Again, it's more of a grade 10 question, but you could potentially get it in grade 11, grade 9 if your teacher was being a little bit mean. Okay. So it says calculate the effective resistance if each light bulb has 3 ohms. So they're telling us this one has 3, this one has 3, and this one has 3. So all 3 light bulbs have 3 ohms. That's their resistance. V1, V3, and V4 are all measuring each of those. Okay? But what you need to realize now, I'm going to get a different color, is that these two are in series with each other. But then this one V2's resistor is then in parallel with that series connection. So the first thing now is to add these 2 resistors together and then treat the parallel separately. Okay, so this is all what you would get from doing past exam papers, is just learning how the different ways that they ask the same thing. Okay, so in the previous question, we had to deal with the parallel section first and then add it to the series. Here, I need to deal with the series part first and then add it to the parallel. Okay, so your R series is just going to be your 3 plus 3, which gives me 6 ohms. Okay, but your 1 over R parallel now is going to be 1 over R1 and 1 over R2. Your R1 is that 3 ohms that they gave you, and your R2 is that 6 ohms that you worked out for the series part. Okay, so 1 over 3 and 1 over 6. So common denominator is 6's. 3 goes into 6 twice. 6 goes into 6 once. So that's 3 over 6, which becomes 6 over 3, which gives me 2 ohms. Okay, so this one is 2 ohms. For the whole circuit. This whole circuit is now 2 ohms. It's a little bit challenging just because you need to know which part is in series, which part is in parallel, so that you can then answer the question. Okay, last question. If the current is 7 amps, calculate V1 and V2. So here is V1. Let me just erase all my drawings so that you can actually see what they've given us. Okay, so here's V1 over here, which is the total, and V2, which is over here in the parallel section. And what did we tell you about voltmeters that are in parallel? Is that they equal each other as long as there's no extra series portion. And there is no extra series portion. So we can just deduce that whatever V1 is, V2 is going to be as well. Okay? So the easiest thing to do is to figure out what we have. So I have the current. Current is your I total. So I have current, which they told me is 7 amps. Okay? I have R total, which they told me is 2 ohms. So I can find V total. So I can find V1's amount. So again, R is equal to V over I. R is your 2, V is what I'm looking for, and I is 7. So to bring the 7 up to that side, it's 7 times 2 is 14 volts. Okay, but they want to know what V2 is. So you need to say that V1 is going to equal V2, which equals 14 volts. So this would be more sort of like 3-4 marks in grade 10, just to prove that you know that they are equal to each other. Okay, so just make sure that you are understanding the basic concepts of electricity, and then the questions and examples that I've just done in this video give you different scenarios. Like I said, the first 8 are mostly for grade 9s, and then example 9 and 10 are for grade 10s, and then easy for grade 11 and 12. But it's nice for grade 11 and 12 to watch these videos so that you can also see the basics and go back to the basics. Because remember, in matric, we don't redo electricity, so you do need to understand for yourself. Okay, thanks, bye.